Hello, good afternoon, everyone. Thank you for waiting and thank you for attending our air quality webinar. This is the first time that we are offering an air quality presentation during the user groups. I attended some of them last year, and it's a shame that this year we can meet you in person, but I'm glad we have the technology here to deliver this event to you. If you were here with us this morning, thank you for staying with us. And if you are just joining the air quality webinar, welcome. I hope you find our presentation useful. Our presentation today is about the practicalities of deploying air quality sensor systems, including local authority case studies. So today's webinar will be presented by myself, Francine Bucco, and by my colleague, Peter Fleming. If you don't know us, we are the air quality team here at Campbell Associates. Just some information about the presentation today. So we have a Q&A box, so feel free to submit your questions. We'll have a couple of minutes to answer them at the end of the presentation. We also left a link for the feedback form. So if you could give us a feedback after the presentation, that would be great. And in this feedback form, you can also request your CPD certificates. So it's there for you. And perhaps my colleague Helen will also send this to you by email if you're not able to do it now. So for today's presentation, we will show you the Aeroqual range of air quality monitors and some of the applications and some of the real projects that our customers have been working on. We know that this was a tough year for everyone, but we received inquiries for different applications, and that's why we thought it would be a good idea to show you the whole range of air quality monitors and the applications. So I will be presenting the Series 500, Series 900, and the AQY. And my colleague Peter Fleming will be showing us the AQS1 and the AQM 65. So we all know that air quality is a big topic. Even during this year that we talked a lot about COVID-19, we were still talking about the air pollution and the associated health effects. And we know that the best way to deal with this issue is by monitoring. So for many years, we have been monitoring air pollution. So one of the ways that we use are the reference analyzers. These are great analyzers. They can be very precise if they are serviced frequently, but they are also big in size. It's not always easy to find the right location to deploy them. They need constant maintenance. And within one AQMA, so within one air quality management area, you have perhaps one monitoring station. So that's why we'll have poor spatial resolution. We are also using the diffusion tubes. These ones are inexpensive to deploy, but they need people to go on site to deploy them and to collect samples every 2 to 4 weeks. And then we will also have only the average for this period of 2 weeks or 4 weeks. So these will offer poor spatial resolution, poor temporal resolution, sorry. And we also have the air quality models, but these models need to be validated. So today, our idea is to show you other monitoring solutions that can help us to identify very localized air quality issues and can help us tackling air pollution. So starting with our handheld device. So this is the Aeroqual Series 500. This is a very straightforward device that is great for hotspot checkings and personal exposure studies. So this monitor works with a base unit. So the base unit is called Series 500. And we need to use a sensor head. So this monitor has a dedicated sensor head for each pollutant that we'd like to measure. So we have available more than 28 different gases and particle sensors. The fact that we have one dedicated sensor head for each parameter guarantees that we will have accurate data for each of them. This monitor can be used indoors and outdoors, so it has a screen where it will show the data, but it also saves data on board, so you can go out, take your measurements, go back to your office and download the data. You are also able to associate the readings with locations. So if you are going out in a day and carrying out surveys in 5 locations, you are able to set up 5 locations in your instrument, take the measurements, and then when you go to your office to analyze the data, you will find the data associated with each location, which is really helpful. It also has some alerts. So if you exceed some levels, it will beep, and then you know that the levels are too high, which is also very useful. So as I mentioned, we have more than 28 sensor heads available, including sensor heads for PM2.5, PM10, VOCs, ozone, and NO2. You can create your own kit, but we have some kits available for outdoor and indoor measurement. So we have the starter test kit, the test kit pro. We have a very nice case that you can keep your monitor inside with the sensor heads. And then it's very easy if you need to go to different locations to carry out measurements. You can just take your carry case and do the measurements. So this monitor is very versatile, as I mentioned, due to the fact that you have 28 sensor heads available. You can monitor different gases for different applications. So here we have some examples of how our customers have been using this monitor. So this monitor became very popular in the UK this year, I believe because people were working from home. So they were concerned about their pollution levels that they were exposed when they were indoors, but also because we have been using, for example, ozone to clean rooms. So ozone can disinfect rooms, so it can inactivate virus, which is very useful now that we don't want to be exposed to COVID. So some of our customers have been using this technology to clean hotels, schools, and even hospitals. And then after this disinfection, they want to guarantee that the ozone levels are low for people to go back in. So this monitor is very useful for this application. We also have one of our customers who is carrying out surveys to identify the best route for people to walk from A to B. So for this application, you can use the NO2 sensor head or the PM2.5 and PM10 one. This is actually very useful, for example, to evaluate children's exposure. As we know, children are more likely to get ill when exposed to high levels of air pollution. So you can use this monitor to evaluate if the place where they are playing, for example, is safe for them, or if the route they are taking to walk from home to school, it's safe, or which route would be the best one to take. Another application, for example, is this one that this researcher at Birmingham University did. So she placed her instrument inside bag that she could wear, and then she could walk around during the day and evaluate the levels of NO2 that she was exposed throughout a day. Another application, for example, would be to confirming that new buildings meet the health and safety standards. So for this purpose, we have a kit. So for example, if a building needs the WELL certification, we have a kit specific for that. But for other applications, you can also personalize your own kits. So the Series 500 is a very useful device if you want to evaluate personal exposure to air pollution or specific gases, to mobile air quality surveys, to responding to complaints from the public. So you know that the public now is aware of the health impacts of air pollution, and they complain about PM levels or, for example, VOCs for industrial activity close to their house. So with this monitor, you can respond to that. You can go on site, you can carry out the measurements, and you can evaluate if you need to be looking more closely to this or not, which is great. We also have the Series 900. This monitor is a fixed indoor air quality monitor. It's very similar to the Series 500. It works with the same sensor heads. So we have the base unit, Series 900, and you can choose the sensor head that you want to use. This monitor is very useful if you want to monitor buildings or rooms. So for example, now that we are talking a lot about children's exposure to air pollution, you can install this monitor in schools to evaluate the air pollution levels indoors. It's also useful if you want to monitor the indoor levels in public buildings or for industrial applications. So if you have specific if you use a specific gas, or if you release gas during an industrial process, you can use this monitor to evaluate if the levels are safe or not. So another monitor that we will show you today is the AQY. So the AQY is a micro air quality monitor. It's very popular. We have units installed across England. This is a monitor to be used for community monitoring studies. It's great to evaluate very localized air quality issues. As I mentioned, the reference analyzers are big in size. It's not always very easy to find the right location to install them, but the AQY is very simple to set up and easy to use. Usually we recommend this device for long-term monitoring. What I mean is at least 3 months of monitoring. But the AQY is easy enough to be moved around to different projects. So you can install it on a specific lamppost that we want to monitor a specific junction or specific problem. And then when you finish that survey, you can move the AQY to a new location and get data for another location. This device is low cost to purchase and service, and it's very simple to be deployed as networks. So a little bit more about the data that the device delivers. So the AQY delivers real-time data for the main urban pollutants. This means PM, so PM10 and PM2.5, ozone and NO2. So here you can see the PM in LED. Here, this is to measure PM10 and PM2.5. We also have here the ozone sensor. So the AQY uses Aeroqual's gas-sensitive semiconductor sensor. This sensor is very sensitive to ozone. It's very stable and selective. We have been working with the AQY for a couple of years, and we are very confident that the ozone sensor delivers accurate data. We know that ozone is not a big problem in the UK. It's a bigger problem, for example, in America. But during the first lockdown, we saw the ozone levels going up, mainly because of the low NO2 levels and also because of the beautiful sunshine that we had over spring and summer. And why it's important here to have the ozone sensor. So this is because, well, to measure NO2, we use an electrochemical sensor. Electrochemical sensors are cross-sensitive to ozone. So that's why we call this the OX sensor, because actually the OX sensor is measuring ozone and NO2. That's why it's important to have a dedicated sensor for ozone measurements, because then the difference between the both data will be the concentration of NO2. This ensures that we will have good quality data for NO2. We know that in the market there are other technologies to get rid of the ozone cross response, but we are very confident that the method that Aeroqual uses is the best solution that we have in the market at the moment. The performance of this instrument have been evaluated for different independent studies. Here we have a link for one of them. So this presentation will be available for you after we finished, so you can access this link to evaluate how the the AQY performs, but I can tell you that the AQY has one of the best performance in the market. About the data, as I mentioned, the AQY delivers the real-time data. So the AQY sends the minute data to Aeroqual Cloud, and all of the data is available on a web-based software. So, which is really good because you don't need to download any software to your computer. You can use your web browser to access the data from your mobile phone or from your computer. So it doesn't matter if you are here in England or if you're on holidays or if you're in your office or if you're walking around, you can access the data from the AQY from your phone. This web-based software is very straightforward to use. You can plot data on charts. If you have a network of monitors, you can plot the data from all of your monitors. So this is very useful to evaluate the peaks and to evaluate if it's a very localized issue or if it's something else. You can also download data from your instruments. And the good thing about having the web-based software is because we are also able to assist you. So we can access your instrument. So if you have any issues or if you have any questions, you can send us an email or give us a call, and we will be able to support you. Just to mention about the data as well. So we have another option that is access the data via API. So I'm not an expert of API access, but I know that some of our customers have been using API access, mainly the ones who have their own dashboard to display data, perhaps from traffic and air quality monitors, and they want to put all of the data in only one dashboard so they can access the data by using the API access. And another option would be to have a public interface that you can share with your community. So you can display data from your monitors and the members of the public then can access this data to know the levels in your community, which is great. So we have the main problem in urban areas regarding air pollution is the air pollution that comes from motor vehicles, so mainly from traffic. So here I put some questions that we have to consider when we are dealing with air pollution. So for example, are children exposed to high levels of air pollution? Are we exceeding the hourly, daily, annual air quality objectives? I know that we need to have the reference analyzers for regulatory purposes, but is there something else that we can do to keep monitoring these levels? Or we identified an air quality issue and implemented a mitigation measure, but how effective is it? And should I be looking more closely to their pollution levels at this busy junction or not? So the AQY is a very useful tool to be used in these circumstances. So now I'm going to show you some of our case studies and some of the projects that our customers have been working on. So the first one is a case study at a primary school. So a local authority deployed one AQY at a primary school's facade for 3 months to evaluate the air pollution levels that the children attending that schools were exposed to. So here the problem is that the school is located close to a busy junction. I'm pretty sure this is not the only one, unfortunately. And the school's road is the single access for vehicles accessing and exiting a large housing estate. And pollution in this area comes from the vehicles accessing the housing estate and also parents driving their kids to school. This school is located just outside an air quality management area, so it was well known that the levels in that area were quite high. So the parents were complaining because they were worried that their children were exposed to high levels of air pollution, and also the local authority want to make sure that they could identify the levels and propose mitigation measurements. So the advantage of using the AQY for surveys like this one is that the AQY will deliver the minute data. So very near to this school, precisely 75 meters away, there was a diffusion tube site, but the diffusion tube site only gives an average over a long period of time. So in this case, like a month. So looking at the monthly concentration, the average was just below 40 micrograms per cubic meter. So if you don't know, for NO2, the annual objective set up by DEFRA is 40 micrograms per cubic meter. So the diffusion tube was showing the average just below that. So if they were looking only at the data for the diffusion tube, everything looked all right. But when they deployed the AQI, they could evaluate what was happening on a daily basis. So here we can see a chart over a period of time of a week. And we can see that during the weekdays, we have 2 peaks every day, and they were about 8 in the morning and 3 in the afternoon. So these are the periods that the children are either arriving or leaving the school. And these are the periods that the traffic would queue outside the school. So here, the local authority could identify that the children were exposed to high levels of NO2. They also evaluated the PM2.5 data, and as you can see in this chart here, the annual objective for PM2.5 is 25 micrograms per cubic meter. So here we just have one exceedance. So PM2.5 in this case were not a big problem, but you can see the NO2 data that the peaks were reaching 100 micrograms per cubic meter in many days. So this study was carried out just before lockdown. So after they got the data, the schools were closed for a couple of months. So they didn't implement any mitigation measure at that time. But I'm sure the local authority is now looking into doing something, which is good. We have another case study here. So this one was an air quality monitoring at a bus stop. So this bus stop is located in the underpass at Lancaster University. So it's not the best idea to have a bus stop inside a tunnel. We all know that tunnels have very little ventilation. So the university was concerned that the students were exposed to high levels of NO2 when they were waiting for the bus. So here, our customer decided to deploy the AQI for 5 months. So here they evaluated the levels for 4 months. So here you can see in this chart, this before period, we can see that the levels were reaching 100 micrograms per cubic meter in many days, sometimes almost 150. So during these 4 months, they identified that yes, air quality was a problem. The air pollution actually was a problem in this tunnel. So they decided to implement mitigation measures. So in this case, they implemented a one-way system and a low emission zone within underpass. And in the following month, they evaluated how effective it was. And we can see here in the after period that they drastically reduced the NO2 levels. So if before the peaks were reaching almost 150 micrograms per cubic meter, after the implementation of the low emission zone and one-way system, the levels were not above 50 micrograms per cubic meter, but mainly between 30 and 40. Also, we can see here that the minimum values remain the same, but it had a huge impact in the peaks. So the AQI, it's a very useful tool for this kind of survey, and we were really happy that we could help our customer to reduce the levels in this application. Another application would be for smart city projects. So we have been talking a lot about smart city projects. So this is basically integrating different sensors to improve life in big cities or big and large urban areas. So a customer of ours, Telenza, they have been working with Suffolk County Council, then deployed a pilot network of AQIs and also other sensors related to traffic monitoring. So Telenza is a lighting company, and they chose the AQI because the AQI it's not only delivers accurate data for the main urban pollutants, but it's also very easy to deploy. They can access the data via API, as I mentioned before. This is their dashboard they created for this pilot project, where they can look and analyze the data on a daily basis. Telensa have deployed, I think so far, 20 of our AQYs. And as this project has been successful, they will probably be looking into deploying more monitors. I'm not sure if for this specific network, but probably working with another councils as well. So just to mention projects that are currently going on. So we have school projects. So we have, for example, Dulwich College in London. They've got 3 of our monitors. We also have a local authority using the AQY at a nursery school near an airport to evaluate their pollution levels in that area. We also have London Borough of Tower Hamlets, London Borough of Waltham Forests working on school projects and using the AQY to evaluate how effective it is to close some roads near schools during the drop-off and pick-up times. We also have some other customers working with air pollution and traffic projects. So, for example, we have Wiltshire Council, who just purchased 2 AQYs and deployed in Bradford and Avon. So, for this application, they implemented a one-way system, and after this implementation, they noticed that it's causing congestion in traffic. So they are worried that this will lead to an increase in their pollution levels in that area. So they are using the AQYs to evaluate this. We also have other customers working in clean air projects. So here we can see one AQY that our colleague Steve deployed in London a couple of months ago. So here you can see that the AQY is sitting inside a protection cage. So if our customers are worried about vandalism, we can provide this cage to keep the equipment safe and still take the measurements. So that's it for me now. So now I'll pass over to my colleague Peter Fleming.
Hello. Thank you, Fran. That was really good. So up until now, we've been talking about the AQY and the handheld monitors. These are obviously giving you really good, accurate data, and we've actually been able to prove that by a number of co-location studies. However, it's one thing to be accurate, it's another thing to prove that you can be accurate. So I'm now going to be talking about a couple of monitors which are actually replacements for MCERT analyzers, mainly because they can be calibrated, so we can prove that they're correct, that the data is correct, and also we've got and we can also prove the long-term stability. And it's not clicking on. There we are. Right. So as Fran said, we're all used to having either cabins or cabinets of reference monitors, as in this case. But if you look at the picture in the middle, you can see within the cage is a little AQY, but next to it, sitting next to it, is the slightly bigger system, the AQS, which is basically giving you the same data as you would get from that big cabin. Generally speaking, as with both the AQY and the AQS, we're talking about something which is a lot smaller, it's less expensive, they're certainly cheaper to run, a lot less labour intensive, so LSO visits every 3 months if at most, a lot lower power consumption, and certainly easier to locate and to move. And if move on to the AQS, as Fran said, she's dealt with the equipment on the left. On the right, we've got these 2 units, the AQS, which gives you any 3 gases from ozone, CO, NO2 and VOCs, and the AQM, which enables you to actually measure 8 gases plus PM as well, and the PM monitoring systems are actually the same for both. Okay, so looking inside the AQS, what you've got is for gases, we've got the individual modules for each gas, which can be swapped in and swapped out if necessary. The main one obviously is going to be NO2, but obviously ozone, as I said, ozone, VOCs and CO. The bigger unit, as I said, you can have 8 systems in there, 8 units in there, but that's really going to be for the very, very big systems. I don't think there'll be a lot of those in the UK. The main thing is that both units will give you the sort of data that you would get from MCERT's analyzers. So if we look at this is correlation for NO2 between an AQS1 for NO2, which was co-located next to our reference analyzers. And in actual fact, if you can see the picture that's behind me, that's actually the setup where this occurred. And as you can see, this was over a 3-month period. It was actually during lockdown. I was actually furloughed during this time, so there was no calibration, no interference with either of the reference analyzers or the AQS1. And as you can see, the correlation between the two was excellent. An R² of 0.93 is incredibly good, considering also that we were looking at 2 monitors which were about 3 meters apart. And for ozone, it was even better, with correlation about as perfect as you could get. Not only that, but the stability of the system meant that not only were we getting good correlation on the 2nd of May, which was the first peak that we had, but we were still getting the same sort of correlation at the end of July. And as I said, this was still on the factory calibration. No adjustment had been made since they were built in Auckland. And the same for ozone. As I said, unlike so-called low-cost sensors or small sensors or whatever we're going to call them, which have to be calibrated against by co-locating with a reference analyzer, the AQS and the AQM, we can actually calibrate directly with calibration gases, and that's what the guy is doing here. Although I should mention that he's actually calibrating an AQM, not an AQS, but the main difference is just in terms of size. Particulate for both the AQS and the AQM, and also for the Dust Sentry Pro, we're using an optical particle counter, which an advanced unit which gives us PM1, 2.5, 10 TSP, total suspended particulate, and also particle number, and with excellent correlation. So for example, if we look at correlation with the TRF-GMS, we're getting correlation of R² of 0.73 and better, versus the FEDAS, we normally get something like 0.94, 0.95, or even better than that. And correlation again with the TRF-GMS for PM10, again we're getting really good correlation even on hourly values. It's not moving. Sorry folks. Normal service will be obviously the main difference between these and reference analyzers is just the size and the weight. On the left you can see where Fran delivered 6 systems to one of our customers, Hilson Moran, which have now been in operation for over 3 months now. And in the middle you can see one of our other colleagues, Anthony, carrying an AQS with just one hand. And on the right, you can see one of these units actually deployed onto a lamppost. It's about 13 kilograms, which can be obviously a little bit more than the AQY, and pulling only about 30 watts with either a 12 volt or a main supply. As with the AQY, we're using the same software. So if you've got a network of AQYs and you want a reference analyzer as part of the network, you can have the AQS and all the AQYs all visible at the same time, all on the same system. And again, obviously everything go into the API, and we're beginning to get companies like Ricardo who are now collecting data directly from these units. In terms of applications, as I said, this is going to replace a lot of the MCerts analyzers in some applications, particularly in situations where you're short of space, so roadside, street canyons, etc. You can also use them for verification of your action plans. For example, installing one of these on a road where you change the traffic management to see whether there is actually an improvement. And not only that, you can have confidence that the data you're getting is accurate, is absolutely accurate, and that it is traceable and proven to be accurate. One of the other benefits of these systems is you can get 1 minute data off them, which you could never get with conventional MCerts analyzers. So it now means that you can do live feedback onto traffic management systems, UTCs, urban traffic control systems, as they're now doing in Mannheim in Germany. We can also use them for calibrating low-cost sensors once after installation, for public display, for model verification, research, community, and also rail-related and port and shipping emissions monitoring. And obviously also very useful for source apportionment, where the option of having a wind speed direction sensor, either a conventional one or a sonic, ultrasonic version, it can just be fitted onto the top of the unit or connected to it from nearby. And we're also seeing a lot of interest from people who are doing construction monitoring, construction dust monitoring, where adding NO2 can differentiate between different sources. I'll come to that in a minute. Obviously, we're for various reasons, we've only really been working with these analyzers since just before lockdown, although worldwide there must be thousands of them. And we've got a couple of hundred of the very closely related Dust Sentry. This is a system, this is what happened in Dubai. They realized that they could either have 3 conventional US EPA type MCerts type approved monitoring stations, or they could have 14 AQMs, and they went for 14 AQMs. That's then given them much better coverage, far more detail, and is giving them far better understanding of the air quality, but with the knowledge that the data that they've got is absolutely accurate. Some of the supplementary benefits, though, is they're using 1/10 of the power. There's about 1/5 the maintenance costs, virtually no operator time, so the LSO visits aren't really needed anymore, and they've been a lot easier to install and a lot easier to move if the circumstances changed. And it also I've inserted this slide also just to give you an idea of how better coverage can give you more detail. So this is some work that's been done in California, where the reference monitors were only able to give you an idea of what's happening around the local around the reference monitors, but having, in this case, an AQY, but obviously an AQY or an AQS, having more analyzers can give you far better coverage and far more of an idea of what's actually going on. Another instance where Georgia, this is Georgia in the States, not the country, where they've now got enough confidence in the data that not only is it going to public display on their own website, Air Georgia, but it's actually also going out on the US EPA Air Now website, which is the equivalent of the DEFRA website. They are getting really, really good data capture rates, even despite having been affected by wildfires, hurricanes and tornadoes. So a very reliable, very low maintenance system. As I mentioned before, one of the other areas that's been used extensively in the UK is adding NO2 measurement into our dust sentry, which turns it into an AQS. And as you can see, the first peaks that we've got there, you can see that NO2 has gone up at the same time as the particulate, which shows that it's probably a diesel vehicle. It's a vehicle or an NRMM that's causing it. Whereas the second peak, you can see there is just PM10 and no NO2, and that's more indicative that it's actually dust from a dusty operation rather than a vehicle. Obviously quite important to differentiate those two. I mentioned earlier about calibration of small sensors. We're now at the point where we realise that the AQS was so accurate compared to our MCerts analysers that we've actually switched over to using our AQS for calibrating all our AQYs. And what you're looking at here is the test site that we've got on the fence next to our site. Equally well, it would probably be possible that if you've got a small sensor, a low-cost sensor out in the field, and you want to find out whether it's still reading correctly after you've moved it from your co-location site to your reference, to your final site, then it means that we could install an AQS next to it just to prove that it's correct. But obviously what we won't be able to do, which will give you a little bit more confidence in the data. As I mentioned earlier, I can't say too much about this because I spoke to the guys yesterday and it's still a work in progress. But the 6 systems that Fran delivered about 3 months ago, they're actually being used by Hilson Moran for a rail study where they've got 3 sites with 2 AQS1s at each site measuring PM and NO2 and basically doing, I believe, a sort of an upwind and a downwind study. And we'll probably know more about, I'll be able to talk more about that once their work is published. So if we move on to any questions, I will just open up, and I can't see the question panel.
Thank you, Peter. Thank you for your presentation.
Okay.
We've got some questions here already. So, but before that, I just want to mention that we will send you a link for you with the recordings of the presentation, so you can re-watch it if you want, or share with other members of your team who are not able to attend this webinar. We also have the link for the feedback. So if you could please leave us a feedback, that would be great. That is great for us to know what you think and what you are interested in knowing for future presentations, or if you want us to contact you to talk about any specific project or requirement. Now going to the questions. So we have a question here about, can I hire the AQY on a trial? Yes. So the AQY and the AQS1s are available for hire. So if you want to know the rates, please contact us and we can discuss your project. We have another question about collocation exercises with a reference analyzer using the AQY system. So The question is, how did it compare? So Peter was responsible for some of our collocation exercise. Peter, do you want to take this one?
Yep. Basically, every system that we send out, every AQY we send out, we're doing a collocation exercise, because we're co-locating using that rig that I showed you earlier. And normally the R squared for ozone is something like 0.99, 0.98, even 1 on occasion. And for NO2, you're talking about better than 0.95. But yes, we've done plenty of co-location studies, and it does mean that we've got real confidence in the accuracy and reproducibility of the AQY. And also, actually, if you could just stop sharing your screen a little more, Fran.
Peter, if I stop sharing my screen, they will just see a blank screen. So,
all right, okay.
Is there anything you want to show?
So basically, what I was going to show you is that we've got a trial going on at an AURN station at the moment, and basically we've got 2 AQYs which are tracking each other exactly, but more importantly, they're also tracking the AURN data exactly as well.
Yeah, so perhaps if anyone wants to get more information about this trial, they can email you, and then you can contact them to talk about this.
Indeed, or ring me up as long as it's not Fridays, because I'm still not working on a Friday.
Okay. I hope this answered your question. So do we have any more questions? Not at the moment. So Peter, I have a question. So can you tell a bit more about the difference between the AQY and the AQS1, and when we would recommend the AQY to be used and the AQS to be used? Because it seems like the customers usually have questions about whether they should be using the AQY or the AQS1 for a specific application.
Yeah, I think if we differentiate primarily between low-cost sensors, which includes the AQY, we are told by many people that the AQY is the best of them, but the main difference between the two, as I said, is the fact that not only is the AQS producing accurate data, we can prove that it's producing accurate data in place by putting calibration gases through, and that's what makes it. That's what is the game changer, as it were. It also means that you don't have to rely on any reference station data. It wouldn't matter if you don't have your own monitoring station, and it takes us onto a totally different plane in terms of monitoring.
Okay, thank you, Peter.
I can't see any questions. Fran, can you?
So another question here would be, can I let my colleagues or elected members see the data directly? So yes, it is possible. So if you are accessing the data on Aeroqual Cloud, we can give access to your colleagues to access it. But if you want to make the data available for the members of the public, then we would recommend you to use the public interface, because then they would only be able to see the data. They wouldn't be able to see the settings for the equipment. Okay, another question here, Peter. How often do AQYs need to be co-located for calibration?
Yeah, that's an interesting one. Certainly early on, we were talking about having co-location every 3 months. But I think we're now at the stage where we understand how they're operating so well that probably the only reason to take an AQY out of its installation is to change the sensors, which is normally every 1 to 2 years, and probably do the calibration at the same time. What we are finding is that once we've calibrated or checked the calibration at our offices, we're finding that the span, the gain values are remaining constant, and we can rely, but even on the factory settings, and we can adjust the baseline quite easily as well in place without having to do a co-location. In actual fact, what we are finding is that the co-locations don't really provide much of a benefit, because with all of these systems, and it applies mainly to the electrochemical sensors, when you move them, they change calibration. So calibrating in place is probably the best way to do it. We've also got some other software which we're just trialing at the moment, which will enable us to do a full calibration in place without having to do any co-location at all.
Okay, thank you, Peter. Do we have any more questions? Still have a couple of minutes if you want to submit a question. Okay, so I believe we don't have more questions for now. Oh, no, we have one more. So the question is, can any of these monitors be used for LAQM purposes?
Yes, they can. I know a lot of people get very worried about, that I must use an MCerts approved analyzer. But having worked obviously at TRL, where they were doing the assessment of the annual status reports, the situation is that, and also having spoken to DEFRA, the situation is, as long as you can prove the accuracy of your data, then there's no reason why you can't use AQYs or AQSs and report that data as part of your ASR. I think so. Certainly, so it does mean that you should not need to rely on expensive and time-consuming reference analyzers anymore. I hope that's answered the question.
Yes, thank you, Peter. Do you have anything else to add?
Not at this stage. I think the main thing is, obviously, what we've presented here is quite a range of different options, a range of different analyzers. I quite often I will get a request, can you quote for the Aeroqual analyzer? And you now realise that there are a number of these. And I think if you've got a particular application, a particular need, then please just contact Fran or myself, and we will be more than willing to help and sort out just what the best instrument for the job would be. And even if it turns out that the best thing to do might be diffusion tubes, we will tell you. Okay. Okay.
Thank you, Peter. Thank you for everyone for attending this webinar. I hope you enjoyed it. I look forward to hearing from you. As Peter said, we are here to help you. Come to talk to us. I also would like to say a big thanks to our colleagues who helped us organizing this event and helped us to deliver this. So thanks, Helen, and thanks to Joanne as well. And that's it. So have a good afternoon, and I hope to hear from you soon. Bye.